Standard normal distribution is a normal probability distribution with the mean mu equal to 0 and the standard deviation sigma equal to 1. The total area under its density curve is equal to 1. And again, that's true for any continuous probability distribution. So here's a picture of our standard normal distribution. And this is really just a special case of a normal distribution. It's just that it has a specific mean, which is 0, and a specific standard deviation, which is 1. And it actually corresponds to the z-scores that we talked about in Chapter 3. Because the values of the random variable here correspond to z-scores, we use the variable z instead of x when we're talking about the standard normal distribution. Here's an example with the standard normal distribution. For a standard normal distribution, what does the area under the curve for z greater than or equal to 1.5 represent? What does the remaining area under the curve represent? Here's our picture again. And if we put in the value of 1.5, and since we're talking about the area under the curve for z greater than or equal to 1.5, we're going to shade from here over to the right. And again, you're going to be shading in the same direction as your inequality points. So this area that we've got shaded represents, 1, the probability that the z-score for a randomly selected member of the population is at least 1.5, or another way to think of it is it's the proportion of the population with z-scores of at least 1.5. The remaining area under the curve, in other words, the part over here that's not shaded, would represent the probability of the complement of the event z is greater than or equal to 1.5. So this part that's shaded is the probability for z greater than or equal to 1.5. The part that's not shaded would represent the probability of z less than 1.5. And remember, we said the total area under the curve had to equal 1. So if we knew the area of the shaded region, then we could find the area of the unshaded region by subtracting from 1. So there are two methods for finding the area under a normal curve. One is using tables, and the other is using technology. Using tables is the old-fashioned, sort of old-school way to do it. And again, if you're using statistics in the real world, you would be using technology. So that's what we're going to do in this class. We are going to use either your graphing calculator or StatCrunch.